All right, this is View Calc class, and we're doing topic 3, which is the limit definition of a derivative. So we need a little bit of back information before we can sort of dig into this, and some of it's listed in your packet, but let's walk through some stuff anyway. So we have this curve, y equals f of x, random curve that I just drew, okay? And I've labeled 2 points on here. I've labeled the point x comma f of x, and the point x plus h, meaning that this thing is h units away from the other spot, right? And so x plus h comma f of x plus h. So if I were to draw a line between these 2 points on the curve, this is what we call a secant line, okay? So a secant line, similar to, it's the same word as the secant that you know about from SOHCAHTOA and from trig. So it's a secant line. It's between 2 points on a curve. So 2 points on a curve, okay? It's also interesting that a secant line in a circle is the same line in a circle, right? So, or in a circle if you're in geometry. So like if you were in geometry class and you were asked what this line is, this line would be called a secant line because it goes through 2 points in a circle, okay? Now, if I asked you to find the slope of this line, you would do the same thing you usually do to find slope, which is you do y2 minus y1 over x2 minus x1. So if we did that here, and I'm going to call it ms for msecant, okay? And that's not like a fancy notation. I'm just going to say m sub s for the secant line, slope, okay? If I did the y value, I'd get f of x plus h, right? That's this y value, minus the other y value, which is f of x, over the x value, which is x plus h, minus an x. So what you'll notice is that my secant slope, this m sub s, is f of x plus h minus f of x all over h, right? Okay, so that's the slope. Now, calculus is built on the idea that we don't actually want to approximate the slope using 2 points, but rather that we would like to be able to find the instantaneous slope of a curve at some point. So let's say I want the tangent slope at x. Now, I did a bad job drawing this, so this actually looks a lot like the tangent slope, but just bear with me here. Maybe I should angle it so it's slightly better. Let's just pretend it's down here a little. Okay, so let's make my secant line look like a little bit different. Again, it's just that I did a bad job of drawing it, and I happened to accidentally give you one, let's call it that point right there. All right, so still not particularly great, the job I did, but that's okay. We'll make it work. So we're going to pretend that's down there. Okay, so if I want the slope of a line tangential to a curve, or the tangent line, what we mean is we want the line that only touches the curve at one spot, okay? So if I inch this over a little bit, a tangent line touches 1 point on a curve, okay? On the curve like you see here, or on a circle, right? So the tangent line in a circle would be this line that goes on the edge right here, or on the bottom of the circle, but the same idea touches once, okay? So all of calculus is built around this idea of wanting to find the slope of a tangent line, meaning what is the slope of a curve? Curves aren't lines, they're nonlinear. What is the slope of a nonlinear curve at any given point x that we have, right? And so essentially it's the same equation, but if we were trying to approximate this, right? If I wanted to approximate this green slope, what I would do is I would pick closer and closer points together. I'd make h smaller and smaller and smaller, right? Because I need 2 points to find the slope on a curve. I can't find the slope of a curve with 1 point because that's not the formula. You need 2 points. But if I wanted to find the slope at a single point, what I could do is I could move h to be a smaller and smaller number so that the 2 points get closer and closer together till they get so close together that for all intents and purposes, they are the same point. Well, we have a way to do that now. So the slope of my tangent line is this same formula, right? So mt is the same formula, but instead of having just some random h, we want the limit as h gets impossibly small, meaning what is the limit as h approaches 0? So this thing right here, right? This is the equation for a slope of a tangent line at any point x, but it actually has a name in calculus. This is called the first derivative of f, and it is abbreviated f prime of x. So the limit definition of a derivative, and you're going to learn much faster ways to take derivatives over time. The limit definition of a derivative is that f prime of x equals the limit as h approaches 0 of this big old quotient, f of x plus h minus f of x all over h. So that's what we're going to do in this particular topic, is we're going to go ahead and find some limits, or find some derivatives using the limit definition. All right, so we'll start example 1 in the next video.